how many engineering branches are there from civil?
Environmental.
Hundreds?
Probably like 10.
Geotechnical. Yeah. There's like you can drill down quite specifically, even within like geotechnical, for example.
Yeah.
Or structural.
Like even within geotechnical, there's like different.
I mean, there's more like areas of specialty at that point. You can have people that specialize in like rock mechanics, which is like how do you do like rock cuts, either for like a big like mine pit slope, like looking at like a big hole that's, a mile deep kind of thing, and you're trying to make sure that that whole like hillside doesn't come caving in, or you're looking at seismic stuff. So there's people that are like seismic specialists, so working with like how the ground responds to an earthquake, like 10, 50, 100 kilometers off the coast.
Right.
And how does that affect your building at a very specific location? Or you're looking at like tailings engineers. So mines produce a lot of waste. That waste gets stored in these massive dams. And so, but the mine waste has very specific characteristics. So there's people that specialize in like, how do you contain this stuff in a dam?
Yeah.
And then there's people kind of more like me, I would say more generalist, focusing on like transportation, deep foundations, shallow foundations, slope stability,
Right.
stuff like that.
So basically, there's an engineer for pretty much anything and everything.
Yeah.
For a lot of things in society.
Yeah.
Pretty much everything you see around you.
Yeah. Like all the built world that, you rely on for like safety, just getting places, all has been engineered.
Yeah.
At a general level.
Right.
I think civil, they call it the study of the natural and built environment.
Yeah.
So
Right.
it's like pretty much everything around you.
So what's structural? Like what's a
Well,
is
it'd be
that?
like structures. So I think typically people think of buildings, but then there's also bridges and other transportation structures.
Yeah.
Airports, roads, sidewalks, train tracks, everything has. Like
So what's the process, man? Like take me through it. Like someone listening right now to this have no idea what engineering is, civil engineering, that matter. What goes down? Like what in layman terms, what is civil engineering and what's the process like? Like take us through it.
Well, that's a loaded one for sure. The way I see it is like people work in 3 different areas. There's the people who like are the ones funding the projects, usually big private or public client, the government of some kind. Then there's the people designing it, right, the consultants. And then there's the people building it, which is like the contractors. And then these teams of people work together to create different things in our built environment. So whether it's a high rise or new railway track, road, a bridge,
Yeah.
Right.
a mine.
Yeah. So the people that are funding it at a high, like they're called the owner. So if you kind of take the process all the way back, so somebody owns infrastructure, right? So whether that's the railway, whether that's the government that owns all the highways, whether it's another private client that wants to build a building, a developer, they have an idea of what they want, right? So then they kind of decide at a high level, like we want to spend about this amount of money to accomplish our goal. So they do some internal studies, figure out what their options are. Then they'll approach a consultant, and that consultant then takes that high level idea and they work to kind of make that a reality. And there's normally like a few different iterations of the design. So you come through like what we'll call like a 30% phase. So very high level conceptual, give you rough idea of what it might look like. So, for bridges, let's say there's like a number of different types of bridges. So there's like, if you think about your classic, like your Lionsgate, your suspension cable bridge, or your second arrows, which is like a steel lattice type structure.
Right.
And so what type of bridge is going to work for this?
And these are all the owners wanting to build the bridges.
Yeah. The owners want to build it.
And by owners, you mean the government or who?
Could be the government.
It could be generally for like big like highway projects, it's the government. But if you have like a railway, then the railway wants to build a bridge, then that's the railway. They're a private client. They're doing it.
And do they come to you first to ask for advice because you could tell them, no, this is not a good place to build a bridge, or
Yep.
Yeah.
like is that what it is? Like what's going on?
A lot of owners have like their own engineering departments, so they can do like high level studies themselves to understand what they want and what they need. But then at a certain point, owners tend to be kind of generalists. They're looking at budgets, they're looking at like high level conceptual ideas, and they also have a lot of like what we call O&M type work, so operations and maintenance work that they have to worry about. So they're generally like too busy to like go through the nitty gritty and don't have the staffing capacity to like
The specifics, and then
to do the hard, like the detailed calculations that you need to do to actually like bring a design from this concept to reality. So then when they get to a certain point, they know what they want, they know where they want it. Then they go out to a consultant and they engage them and say like, hey, this is what we're looking for. Can you take this to the next level?
right, and you can say absolutely fucking not, or yeah, we can do this. Like you'll give them advice where this is probably not going to work. There's literally no way, logistically, space wise, land wise, equipment wise, that this is ever going to work.
Your role is more of a problem solver. So, it'd be bad form to come in and just say flat out, like, can the project, we're not doing this, is a bad idea. Part of the job is managing client expectations, right? So they may really want to go in one direction, and you might say, well, we have some concerns. We think maybe, you should consider these things and perhaps go in a different direction and frame it that way rather than like, this is a bad idea, don't do this.
Right.
But
What would some of the things be where you would probably advise them to not go that direction? Like what are the factors involved in?
could be a lot of different things.
Yeah, so like you can look at, let's say you're widening a highway, for example, right? And you have one side of the highway that has like a big farm field, flat ground kind of thing, and then the other side of the highway is like a big cliff. And the owner's like, well, we really want to expand it on this cliff side because we don't want to purchase property. And it's your job as the consultant to be like, well, we can do that. Like that's something we can do, but that's going to cost you a lot of money. And there's a lot more risk involved. Like
To go to the cliff side.
So maybe it's worth waiting a year or two, do the property acquisition, go through that process, and just take kind of the easy route.
Because that might actually be cheaper than the route you're going.
Yeah, exactly.
Right.
So, and then there's like things like some clients like want to like, they might want to build a bridge in one area, and it's like, well, if you shift it like 100 meters that way, you know, it's quite a narrower location, so your quantities go way down. Your bridge needs to be way shorter. So maybe that's like something you can think about,
Right.
kind of thing. But generally, like you have these conversations pretty early on, and then once the tone and the expectations are set, then it's your job as the engineer to be the problem solver that fixes or that makes their dream kind of a reality.
Right.
Yep.
So basically all the stress is on you guys.
Yeah.
All the mental.
It's a high stress job, and we are like personally liable for a lot of the stuff we do. So, you know, if you do something that's because you're taking the public safety into your hands, right? When you do engineering work,
Just. Yeah.
right? You don't want a bridge falling down. That would
Yeah,
obviously
just
be-
collapsing.
That would
in
be
the
terrible.
middle of-
So someone needs to be responsible for that,
Yeah.
and you can't just put all the blame on like a corporation that can just fold and go away, right? There needs to be like a professional who's held accountable.
Yeah. And like with like high complexity projects, there's multiple layers of checking that goes on. So you have your consultant that comes up with the design, they submit it to the owner reviews it. They generally have like a technical panel that can review stuff and make sure that, you know, you're not missing anything. Everything is generally in line with what they want. And then the way the industry is moving right now, based on some like previous collapses and failures. So like there's like been like tailings dams collapse in Mount Poly, for example, which is in northern BC, kind of near Quesnel. Like there was a big tailings dam failure in 2014, somewhere around there.
Environmental devastation, by the way. You should
Yeah.
look this stuff up because it's scary how horrible these events are.
Yeah.
Jesus Christ.
Stuff like that. There's been
Like toxic sludge, basically.
tailings
oozing
dams
through.
failures in Brazil.
It's awesome. It's great. Sign me up.
And it's very
Like,
dangerous. Yeah.
Is that almost sometimes out of the engineer's hands though? Because external factors.
That one there was blame, I think.
Yeah.
There was blame. What was the blame?
I don't know
Found.
the exact details.
So there's a number
You
of
don't know. You can't disclose it.
no, it's all
it's public record.
It's all public.
You can go
record.
look it up, and I think they've find them now, or
I can't remember what the punishments are, but basically it kind of came down to like there was a kind of a more junior staff that was put in a position she probably shouldn't have been put into, just because there was some staff turnover and she was kind of the most experienced person on the project, and so she kind of got put in a bad situation. But they did kind of level professional charges against 3 of the people that were involved in that project.
Jesus.
And like that, when you were talking about professional charges, so we're governed by a professional association here in BC. So it's called EGBC, Engineers and Geoscientists of British Columbia, and they're in charge of making sure that the profession kind of runs the way it's supposed to. And if people have concerns, you're allowed to like file complaints against professional engineers.
So like in medicine, like College of Physicians type thing.
Yeah.
Same idea.
Yeah, same
Bar
idea.
Association for
Right.
Law.
Yeah. And so like they're also in charge of disciplining their members. So when they have these complaints, they're responsible for going through and looking to make sure that you followed like the general guidelines and you're upholding the standard of an engineer. And then you can face disciplinary action. So that's, you can get fined, you can have to go back to take some courses to refresh your knowledge, take tests, or you can, like the most severe is like you can lose your professional license altogether. Right. So
yeah,
it really depends on what the infraction is, but it governs everything from like your technical abilities, but also like how you communicate outside of in a professional environment too.
Is it more so statistical things that you guys deal with, like the math of it, or is it more also thinking outside the box?
It's both.
It's a bit of both, right?
Right. It's our job is like applied science. That's what my degree is in, and it's taking science concepts, physics, math, and then applying it to a problem and trying to solve it. So yeah, you do have to get creative. You do have to think outside the box. But then yeah, you're doing math on a piece of paper, on the computer,
on a piece of paper,
or whatever, right? Like it's both. So some people do science, and it's kind of you just focus on the science itself and less so on the application. But our job is very, very focused on like taking those concepts and then applying them to a problem.
Respectfully, man, I would never. It's not my type of thing. Like engineering, I guess. What got you into civil? What got you guys into engineering? Because it's not for everyone. I'm assuming, right? It's a very, it's a very exclusive type of industry where if you got to have some sort of like general interest in this kind of thing. I guess what got you into it? What drew you guys into it?
So even people who graduate from engineering, a lot of them don't end up working in engineering. Like an engineering degree, it can be applicable to a lot of different industries. And so, anyways, from the people who I know, a lot of people who studied engineering don't even actually end up practicing.
I've heard a lot of, that's one industry I've heard, like the degree that people get. I've heard a lot of people graduating, but then not even going to engineering. They realize that they're not even interested in engineering. They just got the degree. I've heard that about engineering. I don't know why.
Yeah, because like engineering, like when you get in your degree, and I can go back and tell you why I got into it, but it's basically a degree in like problem solving, right? Like you're learning how to take a problem that's presented in front of you and work through solutions, and that's very useful not only in engineering but in finance, in business, and a lot of other disciplines. So like it is like, if you do enjoy engineering, like it is quite a rewarding and fulfilling career path. But some people, like, they want to take this and go somewhere else with it, and I think that's totally cool too. But you're just learning how to like work through problems, how to like approach problems in a logical way. They take like engineering school takes out a lot of the, I don't want to say a lot of the creativity, but a lot of like the kind of the emotion out of decision making, and you're looking at it a very analytical way, and that's really valuable to a lot of different different industries.
Industries, yeah. So you could use that degree to a lot of different disciplines.
Learn how to work under pressure, meet really tight deadlines, work with a group of people to solve a complex problem that doesn't have any one right solution. Yeah, so it's a valuable skill set that a lot of employers look at and say, hey, we could use someone with this skill set, and then maybe you're not actually practicing hardcore engineering, per se.
Yeah. So I have a lot of issues with fucking Vancouver traffic, man. It's so awful. So, and I just feel like it shouldn't be like that. There's no reason why it should be so polluted and congested it is at times, especially from North Van. People listening from North Van, dude, it's so bad. It's so bad. It's getting worse every year because I can see like the line getting more and more fucking longer every year it goes by. Like the going from Cap Road onto Lionsgate and even from the highway going east from North Van, it's just fucking abysmal. Like, is there any, like, first of all, in terms of infrastructure in Vancouver, what would you grade it out of 10? I know you can't really talk shit because that's, like, 10 being we're using the land and everything to the highest bit of efficiency. 0, we have absolutely no idea what we're doing with our roads, bridges, and everything else.
Better than Toronto, I'd say.
Yeah. I mean, there's like
the Montreal's falling apart.
There's like professional associations that go in and grade infrastructure and development in like a very robust way, but like as like a gut feeling, I would say Vancouver's probably like a 6 out of 10.
Yeah.
Like we're not perfect by any means, but like we're better than a lot of places. Like we have a lot of good public transit here.
That's a great point. Actually, I wanted to bring this up just as a non-civil engineer, like my take on this too, because I think that, you know, everyone wants easy answers, but I think there needs to be some kind of multi-pronged approach because obviously we've got more and more people moving here all the time, and the solution isn't necessarily, well, just build more bridges. Right? We need better transit too. We need to get people out of cars as well. And I think if there was, I'm going to try to make this broad because obviously not everyone listening to this podcast lives here in Vancouver or even Canada. We've got American friends. We've got people all over the world. So as a broad approach, I mean, I think it's fair to say that we probably need more subways. We need trains that bypass these bridges, right? To, you know, we have a lot of cities, not just Vancouver, have very old infrastructure. The Ironworkers Bridge is a perfect example. This was not designed for the amount of cars going over that bridge every day. And nothing is going to solve that short of tearing down that bridge and build another one. But then you still have the issue, eventually you still have more cars. So I don't know what your take is, but the solution can't just be build more bridges too, right?
Well, you can't build them fast enough. The population is growing too quickly you can't build like a highway or a bridge or enough capacity for every single person to have a car. You need to offer them other alternatives that are just as convenient.
Yeah. And it's really coming down to like people want to be able to get where they're going quickly, right? And if you don't offer them a way to get where they're going quickly and efficiently, you know, they're never going to use it. You kind of have to have everything in walkable distance and offer them lots of options. So like having transit connectors like light rail, subways, or even like a commuter rail kind of similar to Ontario's Go train, where they're connecting, you know, cities 100 kilometers away.
Right.
That's something that you need to go explore and go down, right? You need to have enough transit that feeds to key lines so that you're able to take a 20-minute bus to a train, hop on the train. You're not even thinking about what you're doing. You can do some work on the train if you're in an industry that lets you do that, or you can just relax and kind of not stress about driving and transit. But those are all things that, you know, a world-class city has. Right? Lots of options. Everywhere's walkable within a transit hub, and you're able to go from A to B in a relatively quick amount of time.
Yeah, go ahead.
I view part of the problem as it's not necessarily politically expedient for today's politicians to put a lot of money towards these big projects that will make a really big difference 10, 20 years in the future when they get delivered in full. So, you know, I think there's a political angle to this where people will just say, all right, they come in, the traffic's bad on Lionsgate, for example. Oh, we want to widen Lionsgate. That's a quick little project we can do in a year or two. We'll widen that one little section. It'll look good on me for my term while I'm in office. And then the next person can deal with the rest of the traffic. It takes, I think, someone who's probably more selfless than a lot of people in politics today to come in and say, okay, no, we're going to lay out a plan, like a 10, 20-year vision of what transit in this city looks like. And here are the steps we're going to take. And this isn't going to get built while I'm in office. It'll continue forward over many generations of people. And you need to do something like that in order to actually try and address some of the major issues like congestion.
Right. And no politician's willing to do that right now.
Well, it's just the incentive is not necessarily there. Toronto is a great example, right? They kicked the can down the road a really long time before expanding their subway network. It's like famously bad, right? First, how big Toronto is, their subway system is very, very small. And because it takes a long time to build a subway, it's not a quick endeavor. Very technically complicated, very costly project. So, people in office look at that and say, do I really want to plunge billions of dollars into this project that probably won't get delivered while I'm in office, so that my next political rival can take
He's gonna take all the credit for it.
Even though it is it will benefit people's lives. But these projects also become boondoggles a lot of the time, right? Like the Eglinton LRT, I think locals in Toronto are very upset about how long it took and how over budget it was. Mm-hmm. So
that's something that like engineers and owners famously struggle with is like schedule and budget estimates, right? Like we do our best with the information we have at the time, but there's always stuff that changes, and it's like it's hard to communicate to like engineers have a hard time communicating to the general public like what project risks are, and like how that's accounted for. And like a project might be over budget, but like there's stuff that you encounter outside of your control, right? Like when you're doing geotechnical investigations, let's say you're doing it on a tunnel, you have a limited number of drill holes. You're not excavating the whole line and then deciding how you're going to design it. You're taking drill hole information, which is, like a 6-inch diameter hole. You're doing a number of them over the alignment, but you're still like kind of like little pinpricks in the ground is what you're looking at and trying to decipher and use your judgment to see what's there. But there's always going to be stuff that you don't expect to be there. And that's why like you're always kind of optimizing your design, updating your design and trying to change it for stuff. But like a lot of the problems with transit and traffic in like Vancouver and then in the world in general is like there's a lot of easy technical solutions, but it's the other side. It's the stakeholder engagement. It's talking to other people. And
there's a whole other side of it that people don't know.
Yeah.
People are always just like, oh, why are we not doing this? What's holding us back? What's the holdup?
Yeah.
And you don't see a lot of that, right? Like all you see is like, oh, they've closed one lane on this really busy road. Broadway is a great example. Oh, they're building something new in town. There's all this construction. People are annoyed by it, right? You don't see anything until the end result as the public. So
are there things being built in Vancouver where you look at and you say to yourself, oh, that's probably not needed. That's probably a mistake. They shouldn't be doing that. Do you have any criticism on things that are happening? I know you can't totally shit on some of the infrastructure happening, but are there things where you drive by or you hear happening, being developed where you think, oh, that's not the best idea?
And if you can't talk about Vancouver, what do you see going on anywhere else in the world?
Like LA, LA's traffic's notorious for being absolutely miserable, and
a lot of
it's
people.
Like a lot of people. That's what it comes down to, right? Like
and people like you. I mean, North America is very like car centric, so everyone has a car more or less. Everyone aspires to have a car. It's a big part of the culture in the States too, right? Having a vehicle, being able to drive around freely. But again, it comes down to like other countries have prioritized offering their citizens convenient and widely available ways to get around that aren't just vehicles. So if you expect people to not drive, you need to offer them something that's like of equal value, right? Something where they'll feel like they don't want to drive or they don't need to.
Yeah, and there's honestly just not enough of it.
No.
Yeah, I don't have really any criticism of any like infrastructure projects that are being completed at the moment. It's honestly more like just like a lack of a lack of funding into infrastructure. Like it's so like the processes and to get the funding and actually execute on projects is so long that, you know, I feel like it's just not kind of happening fast enough. Like it's more I have a criticism that there's not enough infrastructure being built, not doing enough things. So like an example of that is like stopping like Broadway at Arbutus, right? Like I understand the funding mechanisms and that didn't line up, but it would have been nice if they could have made it all the way to UBC in one shot, right? Is an example. But again, there's, you know, that's like a very complicated project where there's, you know, you have 3 or 4 different funding sources. So you have the federal government, the provincial government, the city of Vancouver, and the region of Metro Vancouver, right? All putting money into this project, and it's hard to get all those stakeholders to line up. And then you're trying to do consultations with First Nations and local community members of where you're having stations and stuff like that. So those processes take years to kind of come to fruition.
Right. Yeah. And I guess what would prompt a piece of like a project to start rolling right away? Like let's do this. Would it ever, like you were talking about the flood recovery in 2021?
Yeah.
That's something that's imminent. We gotta figure this out right now.
Yeah.
What was that like?
Yeah. So like emergency response stuff like really kicks people into a high gear. I was able to see a lot of the devastation that happened in 2021. It was quite shocking just how much was damaged and like how ferocious nature can be. It was like I think it was a 1 in 200 year event, and it was devastating to a lot of the infrastructure that we have. And the province was able to kind of kick it out into high gear and make decisions quickly, but that's a very special circumstance, right? That's a circumstance where, you know, you've essentially cut off the Lower Mainland from the rest of the country. Like there was periods in there where, you know, there was no rail connection, no highway connection for a couple months, right? And that's terrifying as a kind of a little piece of land with, you know, a few million people in it. Having no logistical connection to the rest of the country is very difficult.
Yeah.
Most of our freight is shipped by rail and by road, like by truck.
Right.
So when you cut that off, right, you kind of have no choice but to make decisions quickly and kind of push things along. You can consult as needed, but it's kind of like there's sometimes a priority that needs to take place, and that's kind of the safety of the general public. And
right. What went down from your perspective? What really happened just from someone that's in the industry and just the technical side of things? What led to that crisis and devastation?
So, like just to kind of take it back to what the event was. So it was I think it was in November, right? The flooding,
something like that. Yeah.
And so we had like what we call high early snowpack in the high alpine. So a lot of snow, but warm snow, right? And that snow had been sitting there kind of hovering around 0 degrees right on the melting point for at least a week prior to this atmospheric river coming in. And an atmospheric river is like a big accumulation of rain from the Pacific that comes in and hits the west coast here. And we had about 200 millimeters of rain get dumped in a 24 to 48 hour period, which is a lot of rain, but our infrastructure is generally designed to handle, like we've handled that amount of rain before. What really kind of threw everything, and what made this event so devastating was there was all this snow because it was so early in the year, and there was way more than normal, and it was all warm. So the minute this warm rain hit the snow, it melted all that snowpack at the same time.
Yeah.
So instead of 200 mils of rain and getting like 150 millimeters of runoff equivalent, you had 200 millimeters of rain and got like 350, 400 millimeters of runoff, some type of equivalent. So the rain kind of almost like doubled the amount of runoff that you would normally expect to see from an event like that. So you had way more water than normal. And then we had the main one which was, I think was November 21st. But then we had 3 follow-up events, which were also like, you had infrastructure kind of like on the teetering point, and you just kept adding more and more rain events to it.
And
So,
at that point, it was just rain. It was even the snow. The snow was gone.
The
And
snow had mostly been gone.
snow added to the flood, but now it's just
Now it's
the
just rain.
accumulation of rain and everything. Yeah.
Yeah, and you still have like all these watersheds and all these rivers still trying to flow through all that water that had like was running off. Right, it takes some time for all the water to kind of exit a system
Yeah.
and get out to the ocean. Right, so you have high river flows, and then you're still getting more rain on top of that, which is adding to those river flows, those already high river flows.
So basically, there was no way we could prepare for this. This was just like an act of God and Mother Nature saying, "Fuck you guys."
Yeah, I think there's like a lot of our infrastructure is getting older, and we're working through upgrading that, and we're developing right now like all these like through EGBC like all these climate change guidelines, and how do we address these things in the future. But the problem with infrastructure is you can't just like snap your finger and it's replaced, right? Like there's a lot of projects, it takes time to go through, it's a lot of money. So we're working through those challenges as we go, but guidelines are constantly updating, and like our understanding is constantly updating. So, you know, you might build something that's equivalent in the moment that meets standard and meets the guidelines, but when those guidelines change, you know, you need to revisit and reprioritize what your infrastructure is.
Adjust a little bit to things. Yeah.
So it's a constant battle of like updating our knowledge set based on new information and getting that then built in reality, right?
Right.
So it's up to the owners to kind of prioritize like what's important, what level it's at, not only just dealing with like things in general states of disrepair, so end of design life stuff, because these things are only designed to last for so long, right? Like you can't design things that last forever.
Right.
That's not really how.
That's true. I never thought of it like that.
That's not how things work. So you're constantly maintaining and upgrading these systems. So you have to deal with, you know, maintenance of your general infrastructure, and then also looking at, okay, we might have just replaced this bridge, but this doesn't meet standard anymore. So is that a really critical piece of infrastructure for us that we need to replace again, or is it okay in the meantime? But we just need to like keep it on our radar that this needs to become a priority item in 10 years as opposed to 50 years.
I see what you mean now, like problem solving. It's not just in the moment, statistical on the paper, analytical. Oh, this is 20 millimeters. We need this. It's like you're constantly adapting and adjusting to environmental changes. Is global warming one of the things that you guys, and global warming, not just global warming, but like environmental changes and things that are predicted to happen in the next 10 years, some things you guys take into account when you
you have to. You absolutely have to, because events like this are going to become more frequent and severe.
You think so?
Yeah, that's what the science kind of shows, is people expect like extreme climate events to become more frequent, more severe, and to affect like larger areas.
And directly impact infrastructure and civil
Coastal
engineering.
cities are going to have a really hard time in the next 50 to 100 years.
Coastal cities.
Still most cities. Most major cities.
Yeah. Why?
Because the ocean's going to go up.
Right.
And that's going to be...
Is it inevitable? There's no way to save it?
It's not inevitable, but a lot of the stuff that we've done already is going to continue to impact us, even if like all emissions stop today. I think the effects of global warming would continue before they peaked and then started to drop off. So like the actions that you take today aren't noticeable for maybe a couple decades.
So the things that are being built right now, you mean?
Yeah.
Yeah, well, and more like your like personal emissions, like stuff like that. Like the CO2 emissions that you emit now are not going to be noticeable for years, right? So it takes a while and I mean, I'm not a climate scientist, so
yeah, neither am I. Full disclaimer.
Yeah, I don't want to get into that. I don't want to get into that stream, but it's just it's definitely one of those things that you guys have to keep in mind and take account when you're dealing, because you're not planning for the next 5 years. You guys are planning for the next 100 years. Like when you guys are consulting a project, you guys are thinking, what, 50, 100 years in advance of this is going to last, this is going to uphold for that long. And
yes.
Yeah. It depends on
Jesus
the type of
fuckers.
infrastructure, and it depends on the client and what it's for. But like generally, you have design life criteria, and that can be, if it's temporary, 5 years. If it's permanent, you're looking at 50 to 100 years kind of time frame.
Jesus fuck. It's a lot of pressure.
I have a question about, from a technological standpoint, how have we progressed over the last 40, 50 years, or have we not progressed that much? Like, how are we building roads today? How is that different from how we built roads 30, 40 years ago? And also, what kind of interesting technological advancements are we getting now, or are you seeing coming down the road that are going to really make a difference in how we actually build more solid long-term infrastructure?
I think Millar's got this one teed up.
Well, a little bit. So there have been like advancements in materials science, and like building techniques have gotten better. So a good example is like our ability to manufacture cement and concrete has gotten significantly better over the last 50, 100 years. So you're able to control the quality of what you're producing a lot better, and able to manufacture like a better product that's more reliable.
Is it true that concrete's not pure concrete anymore? Because I hear they're experimenting with mixing different materials in it to strengthen it.
Well, concrete has a lot of different components: cement, which is the binding agent, and then like aggregates and other additives. So yeah, there's a lot of research going on right now with adding in different things into concrete. You talked about roads. Like I know, Matt, I think you did a project where the client added, was it like fiberglass bits into the asphalt or something?
Yeah,
Make
they
it
like
stronger?
had like spray on like spray on fiber reinforced layer that they put underneath their asphalt paving to help reinforce it and kind of get over, because it's just like a resurfacing job. So they like, you mill out the top layer, but you still have to kind of deal with what's the asphalt that's below it.
Right.
And so they had this like material that they like sprayed on the old asphalt to help bridge over any of the cracks and movement and stuff like that. But like I think like you're looking at like long-term monitoring and health performance of bridges and other types of infrastructure, and that's something that's kind of coming a long way, is just our ability to monitor infrastructure and like collecting all this data. And Millar can talk about this more, but then training like an AI to like help improve our understanding.
Fuck's sakes.
The way we design like most structures, I'll talk specifically about bridges because it's what I know more about. You want it to fail, if it ever does, slowly and obviously, right? So if you got this big concrete bridge, oh, there's a big crack, right? Oh no, we better look at that, right? Oh, there's rust pouring out of this like steel component. We better look at that. You never want a situation where your structure fails suddenly,
Just fucking
out of nowhere. That's the worst case scenario.
completely collapses
So
in a
this is like-
moment's notice.
That mindset has informed the like design process for bridges for many years, and there hasn't been a ton of innovation to the way people think about that. And so now with the advancement of sensor technology, people are figuring out that you can instrument bridges with sensors and figure out what's going on inside the bridge before something obvious is happening on the outside. And so you can collect data from a bridge while it's in service and figure out, oh, maybe this area is going to experience more wear and tear than another area. And you're able to plan the operation and maintenance of that asset a little bit more effectively. You're able to use that data to inform designs for the future. So it's like, okay, we did this, and it looks like it's wearing out faster than we expected. So we need to adjust our modeling, the assumptions that we made when we designed it. And then just in general, most industries now have figured out that if you collect data on your business practices and use that data to optimize it and make it better, it's like a huge advantage. Right? A lot of businesses have used like huge data analytics now. They're just collecting mass amounts of information from their own business practices to figure out, okay, how can we improve? How can we streamline? How can we make this more effective? And there's a lot of research going on right now in structural engineering trying to figure out the same thing, which is like, how do we get data out of the things that we design and build? And then how do we use that data in a meaningful way to like make our structures more resilient, more durable, and to figure things out for the future?
So it could always get better.
Oh yeah.
Basically.
Yeah.
There's no like endpoint to structure and manufacturing and
The problem with innovation in structural engineering is it's hard to argue with like, oh, it doesn't fall down, So it's like we've done this way for 50 years, and it's if you follow the right, criteria and you follow the guidelines, then your bridges won't fall down. And that's like pretty compelling, right? So you need, certain strength of character to be able to say, no, like I understand the math and the physics very well. I think if we do these small changes, it will have minimal impact to the longevity of the structure. To be able to go outside that comfort zone of this is how we've always done it, so this is how we should continue to do it.
Right. And that just comes out from the thinking outside the box aspect, and really, not being so rigid in the I guess the guidelines of what's now. I mean, like you said, like it's always changing. It's inevitable. It's gonna change at some point.
For bridges, there's very strict like guidelines in Canada for how you can build a bridge, which makes sense, obviously. And you need to have like very, very good, like well thought out engineering reasoning to sort of deviate from those guidelines, those codes, those standards. And they get updated very, very slowly, right? It takes a long time for these codes and standards to get updated with new advancements in the industry. So I think there's definitely a lot of room for like innovation in that space, definitely.
Man, if you look at North Van, for God's sakes, is there any way we can do anything to like add we talked about this in the airport MC. There were rumors, there was a word going around that they were going to build a bridge from Deep Cove to Poco, or near Belcarra area. Would that be efficient? I mean, what's one way you would improve North Van traffic right now? Because it's bad, man. It's so bad. I mean, just Vancouver traffic in general.
I deal with it every day too. It's God.
One?
It's not getting better. They put
one suggestion, maybe a little tweak, a little fucking, I don't know, a little guidance, a little anything, man.
I don't know. It's getting outside my wheelhouse. Like, I'm not a traffic engineer. There's people who look specifically at like the flow of cars on a certain street and how the lights should change and the timing and the signage and all of that.
Damn, there's all of that, huh?
Oh yeah, it's a whole like
that's a whole other. That's another like area of like civil engineering that's like pretty specialized is traffic engineering and modeling all that.
Yeah. So that'd be a good question for a traffic engineer because I have the same question to be honest with you. I drive around.
Well,
and I'm
you're
what
like at a high level,
hell?
like a transit connection that's actually quick, right? Like a SkyTrain connection.
SkyTrain, right?
I think trying to get cars off the road, trying to get cars off the bridges would help, right? You might avoid having to build a new bridge if you're able to provide people with a faster connection from A to B.
I think what we need to move to an entire fleet of automated vehicles. Because if everyone was just sitting in a car and we had automated vehicles and they were all synchronized in lockstep, each car could be within an inch of each other and they're all driving at the same speed. Like, I don't know how that, like, this is pie in the sky thinking, right? Because of course people also don't want to give up vehicles too. But actually, Millar, since your specialty seems to be bridges, I want to know what you think about bridge collapses, because I don't know if you ever heard about this, but I think this happened in the 60s. They made a movie about this with Richard Gere called The Mothman Prophecies, about this small bridge in, I think it was in West Virginia, that collapsed, and they blamed it on this Mothman creature that people were seeing, and it was like this supernatural.
Search up like a demon thing on this fucking on the.
Yeah, and anyways, but apparently they never really discovered what they had theories, but no one really figured it out. And I'm curious, what would lead? How would you not know how a bridge collapsed?
Well, definitely blaming it on like a magical creature is not a good way to start out that process.
and you know what it says in the bottom? You know what it says at the end? The gravediggers would later describe this figure as a brown human being.
You said this in the 60s?
What the fuck? Yeah.
Well,
my bad, Millar.
in school we learn a lot about engineering failures and like lessons learned from those failures and how to avoid them in the future. But the first step of that is acknowledging that there was an engineering failure, not just gaslighting some unknown creature. So I don't know about that case specifically, but there's a lot of very famous collapses that have injured or killed people, which is like it highlights like the very serious nature of the profession, right?
Yeah.
So
one
whenever
of the most famous ones, like the Tacoma Narrows Bridge.
Yeah, Tacoma Narrows Bridge, where they didn't account for like the eddying forces from wind, right? The wind created like a harmonic resonance with the bridge itself. And so you ever see that video of it like galloping? It looks
Holy, the bridge was fucking just
yeah,
in
they called it
waves.
galloping Gertie. Yeah, and it was because it's this phenomena, harmonic resonance, where like the wind basically caused the bridge to like gallop. It looked like a wave in the air.
And that's something that happens. Like that.
Oh, yeah.
That wave is. I mean, when you're going through schooling, that's something that you like.
Yeah, well, they know
teach you
about it
That's
now.
the thing. Oh, well, you know about it.
Yeah,
Right.
luckily in that incident, I think only a dog died, which is still sad, but still better than a person.
But they
Poor
did see
dog,
they
man.
did see this bridge going up and down.
Yeah, there's a
big
crazy
waves, and they
video. You
said
should look it up.
nobody-
Tacoma Narrows bridge collapse, and it's like the bridge is like waving in the air. It's this huge hunk of steel, and eventually it tore itself apart, right?
My God.
So there's a lot of very well-known.
And I'm assuming that like the wind wasn't that. Was it pretty strong? The wind? I mean, obviously, right?
Yeah, it was strong, but it was the way it was hitting the bridge. It was like the angle and the exact speed, and
amplifying
yeah,
the effects of it.
Right.
And like now, like, and this is a profession that kind of learns not through, well, we kind of learn through failures as
course.
much as we do just research, but now that we know like this effect exists, and they do all the big important bridges, they do like scale models of it and like force wind through wind tunnels, and they do wind tunnel tests to make sure that they're not going to get that effect. And so we don't even just rely on the computer simulations of it. They always take it to the next step on really important things. We'll always go and like do scale testing
Right.
for stuff.
I think even computer models, you can't fully predict how it's going to behave. So that's why they do those scale testing. It's like back check against their models. Yeah.
So, would a lot of it be learning through the process of devastation and tragedy? Like these things need to happen for engineering and civil engineering, structural to keep, improving and.
I think sadly a
becoming
lot
more-
of the guidelines are written in blood. Like I don't know exactly, but I think a lot of the reasoning that we use now is based on significant engineering failures of the past.
Well, I should hope that we learn from those.
Yeah.
That's kind of the bare minimum of
Like,
Very
of
important.
course, this sounds very, pessimistic and just really sad. But these things you would say would need to happen for us to learn it. Like in the most simple way, these things need to happen for us to be like, okay, well, let's not make that same mistake.
Ideally, we learn through research.
Yeah, like not trial and error.
and that not trial and
Yeah.
error.
Yeah.
I mean, a lot of
See if this bridge starts collapsing.
yeah.
gonna-
I mean, a lot of the stuff that we know, and a lot of the guidelines are based off of failures that existed at a time where societal risk tolerance was a lot higher, right? Our tolerance right now as a society to deal with infrastructure collapsing is pretty low, right? Like
You think so? It's pretty low.
yeah, we don't like, there's no tolerance for failure, right? We like, depending on the structure, like failure can be like a 1-inch crack forming up, right? Like there's,
Oh, we don't tolerate that.
yeah, we don't tolerate.
Yeah.
we
Okay.
don't-
I
we
thought
don't-
you meant we. Okay. I thought we.
The lawsuits will fly.
Yeah. Even like the slightest bit of like a pothole.
maybe not a pothole. It depends on like owners have to decide if it's worth going down that road or not. But like there's times kind of in the earlier, like as we were establishing as a country where failure happened and they just kind of moved on and okay, well that didn't work. So let's
famously the original iron workers, or what we now call the second Narrows. I mean, it failed when they were building it, right?
Yeah.
A lot of people died.
yeah.
Yeah.
Really? Wow. I didn't know that.
And then same with the like what started kind of the civil engineering governing bodies in Canada was famously the Quebec. Do you remember what it's called?
I think it's Champlain Bridge, right?
Is it
The
Champlain
original
Bridge?
Champlain Bridge.
Yeah. So, but there's this Quebec bridge, and the story goes that they built it the first time, and it collapsed during construction, kind of like a cantilever type structure.
Yeah.
Collapsed, and then instead of going back to the drawing board, the engineer in charge was kind of stubborn and said, no, this will work. And then they tried to build it a second time and it collapsed.
Yeah.
Collapsed again, and then
killed people, like very serious.
yeah.
Jesus.
Yeah, hundreds
That's
of
where the like iron ring comes from in Canada. Like Canadian engineers are granted like an iron ring when they graduate, and it's to
remind you of.
remind you of your professional responsibility. Like double check your work and.
Oh,
get
wow,
it-
I didn't
get it
know that.
checked. Oh yeah, like you have a duty to uphold public
Safety.
public safety,
Yeah.
right? And I think part of the engineering failure with that bridge, from what I remember, was they designed it for like total loading at the end, but they didn't account for construction loading.
Yeah.
So, and the construction loading case actually ended up being higher than they expected and didn't have the supports that they needed to hold it in place. And so, yeah, they had these series of collapses, which were just horrible.
I'll just read it here just to remind, because I even forget most of this too. It says 1958, as a crane stretched from the north side of the new bridge to join the two chords of the unfinished arch, several spans collapsed. 79 workers plunged 30 meters into the water. 18 were killed either instantly or shortly thereafter, possibly drowned by their heavy tool belts. A diver searching for bodies drowned later, bringing the total fatalities. Wow, the diver died too. That is
Tolerance for risk.
Was that just like bad luck, shit luck of the draw? The diver just drowning, or was that had?
Well, who knows with the currents and everything.
Anything to do with the bridge?
I think that was after the fact.
Yeah, that was just like the diver malfunction equipment.
So, like,
Just fuck.
I definitely wouldn't say that those things need to happen, but when failures do happen, it's very important to like learn from it and to move the industry forward to make sure stuff like that does never happen.
Well, here's the crazy thing. A year before the collapse, in 57, a safety inspector from the BC Workmen's Compensation Board had reported that the installation of a safety net under the work platforms were, quote, impractical following the death of another steel worker.
Safety standards are not what they are today.
So what's the protocol that we put in now for the next flood tragedy not to happen? From like, what do we learn from the 2021 tragedy, if anything?
Some people died, right? Mudslides?
Yeah.
Homes just got fucking wiped out.
Oh, yeah. Economic devastation.
Yeah.
was-
Oh yeah.
So, I mean, this is, I think, a little bit more up my wheelhouse, but like definitely understanding a little bit better, like those rain on snow events and how they'll impact the flows. Going through and, looking at from a geohazard risk management standpoint, understanding where your risks are. Geohazards are hard because you can only mitigate to a certain extent. They're large events, and it's understanding the conditions that will lead to failure. If you can't either contain it or you can't support it and like pin it down, then you need to look at, okay, understanding the mechanisms, and maybe we need to close the highway during these severe rain events, wait for it to finish, and then have engineers go out and inspect it to make sure there's no big changes in the condition. And while that might be like an inconvenience to people's kind of day-to-day operation, it is at the end of the day like a health and safety thing. So I know there's also updates to our understanding of flow rates and how we design culverts and bridges and stuff like that for the amount of flow that they need to handle. So we're spanning like all the like bridges are getting wider. A bridge that might not really see that much flow right now hadn't had any issues in the last 50 years. Well, time to make it wider just in case that next event is the big one.
Right.
Just because it's okay doesn't mean it's going to be okay in the future.
Right.
And really kind of moving the industry forward to make sure that we're accounting for climate change, we're accounting for all these severe events,
Right.
and we have a better understanding.
So structurally building something right now in the immediate time is probably out of the question because it's going to take so long. So you would have to take different precautions, such as closing off the highway to account for it, because building something and adjusting for it is probably take years, right? And there's no time for that, especially with the way
You want to be doing both.
Yeah.
So
both.
Yeah.
I think broad lessons learned to be, there needs to be a priority on updating some of the outdated infrastructure assets that we have in North America. Like a lot of our infrastructure is very old. It was built at a different time under different understanding of conditions. So you need to focus on replacing that and updating it for modern times. And then, sort of taking precautionary measures when you don't have the time necessarily to go and update an entire
Is there a bit of
highway.
pushback on changing the outdated things just based on funding and people? like you said before, we talked about before, politicians not wanting to
Yeah.
make the change. There's no prompt to it. Is there a little pushback on that? A little stubbornness?
I think people have views on where taxpayer money should be spent, and so there's always disagreement about what the best use of that money might be. We're obviously pretty biased, but my own personal take is, there should be like more asset allocation to making sure that we have a built environment that is ready for the future.
I feel like for the general public, for someone to agree with that, to be on the side where they're thinking, no, fuck that, let's not invest in this infrastructure or whatever. It just comes down to, if it doesn't affect me, I don't give a fuck.
But it does. That's another thing with those BC floods is you take it for granted, right? You're just driving down the road. Yeah, there's a bridge here. Obviously, I need to get where I'm going. Ironworkers Bridge is here. Lionsgate Bridge is here. Like, of course it's there. Until it's not, and then people freak out. That's what happened with these floods. It's
like Highway 8 that cuts like from Merritt to Spence's Bridge. Like that highway was completely taken out. Like it was not in service for like almost a year, and that people like live along that corridor, right?
And that has indirect effects on us.
Yeah,
Would you say it has indirect effects on us all the way to Port Coquitlam, North Van, Burnaby? Like that far?
Yeah, that one a little bit less so. It'll come a minor highway, but like again, like think about the Coquihalla being cut off for multiple months.
But train routes too.
Train routes.
We
A lot of our
waiting for supplies and things.
Yeah, supply chains fell apart.
Yeah, and then so like you know, and that's one thing that people really never think about is like train infrastructure and like making sure that that's resilient to be able to transport what we need, the goods we need from one end of the country to the other, right? Like you lose train, like I think the Port of Vancouver lost train connection for a couple weeks following the floods, and like, you know, think about the food that was supposed to get transported places, right? Like, it's not going to make the ship that was docked in port. Now all of a sudden it's delayed 2 weeks. That food's probably gone bad, yeah.
You asked earlier about like what got me into engineering, and civil engineering in particular. I think it affects everyday life around you so much in a way that most people kind of take for granted, right? You wake up, your house didn't fall down, you know, the roof, the rain that happened overnight fell off your roof and went and was taken in a catch basin away to a storm sewer. You turn on the tap and it's clean running water. You drive to work on a road that, you know, the water's draining off of it. You know, your Amazon package comes on time because it was shipped overseas from China in a shipping container that was transported by rail and arrived right in time on your doorstep. So it like affects everyone's lives in everywhere, right? Everywhere where there's civilization, you need like civil engineering to make it possible.
That was just the total flex on software engineers. Just a complete like fuck you to actually making a difference in the world.
Yeah, and
I heard there is some
pennies for it compared to software engineers, but yeah.
Really?
Oh yeah,
yeah.
There's so much ridiculous money in
software.
It's annoying, honestly.
I heard there is a bit of animosity between the two disciplines. Not animosity, but kind of just like the software people are like, oh fuck,
like
fuck civil people are kind of like,
as they drive to their work in their office building that doesn't fall down and get clean running water out of the tap and pull electricity out of the power grid to run their computer. Like,
let's go.
Yeah. It's a bit of a dumb argument to me, but
so there's a whole humanity side to it. I don't that's the thing I wasn't too clear on, and this is something I'm learning now. I mean, a lot of people don't know that. People just think it's like you said, MC, it's like sitting in a fucking dark room just with their science glasses on and just like in their lab coats, like looking like doing shit on the computer. But it's a total different. It's like thinking outside the box, and
it's a very exciting and cool area to work in, and meaningful and fulfilling, and you feel like you're really having an impact on the world. So my message would be, if you're thinking about engineering, definitely please consider like civil engineering, because it's very, I think most people who I know who work in this area are have very high job satisfaction, and they really enjoy what they do.
Yeah. Like you get to see, it's really cool to work on a project where you start to interface with the client. You come up with a concept. You work on it on paper for like a year, 2 years, 3 years, and then you go and you see it get built like one step at a time. Like they're pouring concrete today. Oh, they're doing this, they're doing that. They're installing the rebar. They're building like this, building up the slope. And you see it all come together slowly, and it's like, you know, you start out the project, and because it happens over such a long time, you kind of see step by step, and then every once in a while you think back and you're like, wait a minute, there was like nothing here, like 6 months ago. Like this was just a bare ground, and now there's this bridge here, and now it's done, and now there's people driving on it.
Right.
Yeah,
Well, people like you are the unsung heroes, right? Because it's, you know, you're it's got to be,
it's like first responders.
well, it's got to be really satisfying and gratifying in that job, because you are building something. You are building the future. You are contributing. Every aspect of what you do touches everyone's daily lives. They may not be, you know, aware of you, but I mean, you're leaving a legacy behind. And how many people can say that, right?
This should be a promo for civil or engineering school. 100%.
It should be. We need more smart people in civil engineering. 100%, man. Yeah. Like you need to stop going. In North America, there's a big like over financialization of certain industries happening right now. Tech is a great example.
Well, everyone wants to be a software developer.
Yeah.
But for what?
Cool.
For what? To make money?
To make more fart
Is
apps.
that all it's really about? Or, you know, is making society and humanity a slightly better place a little bit valuable too? To me, it is valuable, right? When I look back at the end of my life, I'm going to be able to point to things that weren't there before that makes people's lives slightly better, that's there today that I was a part of. And like, I will be satisfied knowing that I made the world.
That is a pretty big flex. Like you build you're part of something. You build a bridge and you're fucking driving on it. Like this is me. Yeah. This is all me. Fuck you, buddy.
Yeah, it is.
The guy beside you, just
it is cool to kind of like drive on something that you've had a big part in, right? And be able to point to it and say, I was a part of that, right? And it's like, you know, you can say that from the engineering side, but you can also say that from the people on the ground building the thing too, right? Like contractors, people who want to get into construction. Like I would say, like, you know, skip the multi-level marketing and go and get your hands dirty in an excavator and stuff like that, because you'll be able to build stuff and be a part of something that you can point to for years and years to come. Be like, I was involved in that project.
Right, a whole team, a whole community working on one particular thing.
And that's something that I think people forget about with engineering, is like, it is not one person in a dark room kind of doing all this math and coming up with these designs. It's a very large collaborative approach between owners, stakeholders, your design team, the contractors that build it, the environmental people that help make sure you do it properly. It's there's a lot of inputs into these designs, and like a lot of people forget that communication skills are so important in engineering. Like being able to communicate not only within your design team, but even across disciplines. Like it's kind of weird, like structural engineering and geotechnical engineering. Sometimes we actually talk slightly different languages. And so it's important for us to be able to like, wait a minute, this is what he's trying to get at, and I was trying to get at something different. So we got to like bring this back and like make sure I understand what the structural engineer wants.
Like you guys want the same goal, but you kind of look at it in two different ways. You're getting to the same objective, but slightly different ways.
Exactly. And then, but being able to communicate what you want and what you need, and then communicating to the owner of like what's possible, how to manage those expectations, communicating then with a different set of audience. So the contractor, right? You're talking to like people with a variety of different education sets and experience sets, and even like their understanding of something might be completely different than yours, right? They're looking at it from their perspective. So being an engineer and learning how to communicate with all these different groups in the way that they understand it is such a valuable tool. And I think that gets kind of glossed over a little bit in school. But when you go into the industry and you start working, you kind of realize just how valuable those communication skills are.
Like your field of engineering, your field of engineering, Millar, it goes hand in hand. Like you guys, you need MC, you need him, Millar, you need him.
Oh, absolutely.
Right?
Absolutely.
Yeah, they
it's
are
very collaborative in that sense. Not just because you're structural and he's geotech, it doesn't mean it's completely exclusive. Like you actually need to. Is there a lot of similarities though? Like there's things that kind of go hand in hand, and just
there's overlap for sure.
There's overlap, yeah.
Yeah. But yeah, there's a lot to know about each area. So it's hard to be an expert in both. Generally, you pick one and sort of stick with knowing even just a small slice of that knowledge area.
Yeah, or else you just fucking implode.
But having like a structural that understands a little bit of geotech or a geotech that understands a little bit of structural, when you go and you talk to each other, and that's the benefit of like working for a company that has both in house, is you're able to just kind of walk across the hall and
Right.
pick their brains.
You
a little bit.
kind of get where they're coming from when
Yeah.
you talk to them. Yeah.
Yeah, exactly.
Yeah.
Or if I'm, because we don't always work with like the structurals or the geotechs from our own firm. Like sometimes you're still on, like you're working with a different company to do something. So even having like the structurals down the hall to be able to go to and be like, hey, what
Hey, structural, what's up?
yeah, what's up? And like, what does this person mean by this? Like, like what are they trying to get at? Because sometimes like other engineers are not the best at communicating what they want. So it's always good to get like a different perspective on like, what are they trying to get at? And then sometimes it kind of clears things up.
Right. Yeah. So, I don't know if we got a clear answer. We might have. I just fucking completely missed it. But there's absolutely no way of fixing North Van traffic. Hey, at this point, it's pretty fucking.
There's a way.
doomed.
I'm sure there's a way. It's
complicated, though.
It's complicated. Like again, like there's always a technical solution to it, right? Like
Right. Oh, Skytrain, you said. Yeah. I
there
remember.
and and there's like a technical solution of like, okay, let's bulldoze down a bunch of houses. Let's take away the port and add another bridge, right? There's technical solutions like that, but then you got to consider like the stakeholders. Well, nobody's going to want that to.
What about getting Elon Musk involved in building that hyper? What is it called? That thing under like I think they got it in Vegas. The hypertube thing underground.
Yeah, I mean that'd be pretty interesting. I would be down for there to be like a little hyperloop here in the Lower Mainland. Like I think having a hyperloop from Vancouver to Chilliwack, all the way up kind of to Kelowna, it'd really kind of help connect the province. And
Well, yeah, you get there in 15 minutes as opposed to an hour.
Aren't they thinking of making a train all the way from here to Seattle?
yes,
I think so.
yeah, they're doing like studies on the high speed train. I think it goes from like Pemberton all the way down to Seattle or Portland or something.
That would
like
be huge.
Yeah.
That would be clutch.
We need that.
We need that, right?
Yeah, it'd be awesome.
Yeah, more
And that-
investment.
And that would help traffic everywhere else as well.
Yeah.
That's the thing. Like people don't realize. Like
There's a huge economic benefit too. Being able to live in one place and quickly commute and work in another.
Yep. Cost of living, you can live somewhere where the cost of living's lower.
Yeah.
And it makes it more accessible for more people.
You shop and spend your money in different areas, contribute economically.
Because I think max it's 45 minutes to get to Seattle. From what I've heard, like this high speed train, that's what it would take.
That'd
Yeah,
be
which
Which is
amazing.
awesome.
Yeah, that's sweet. But that's probably like a good 10 years from fruition.
Oh yeah.
But that might go faster. Like I know there's like interest from like private companies like Amazon and Google and Microsoft to invest in a project like that. And that's pretty interesting. It's like I think we're going to get to a point where infrastructure is not solely funded by the government, and that private stakeholders are going to want to help fund some of these projects to help them move them along a little bit better. And I think that'll speed up the process.
Right. I feel like they're doing it for their own benefit though.
Yeah,
Sure.
but which
Yeah,
is
sure.
good. Like Amazon is a great example. Like how much of our infrastructure subsidizes Amazon's business model? All their shipping, right?
Roads, bridges,
Yeah.
railways.
And the maintenance of those assets.
I wouldn't put it past Amazon to put forth a concept of just having these like underground lanes only for delivering packages that would go across like from the US to Canada, and they would have like some kind of high speed train and then have packages delivered to the country way faster.
Would that be believable? Underground.
Use more of the underground. To me, it sounds
mean-
great. I think we should do it.
I mean, there's challenges with tunnels, but like there's rail tunnels like right now in the Lower Mainland. Like there's the one that kind of goes from Thornton Yard to the North Shore right now. It's all underground. It's quite long.
Yard. How do I not know this? It's North Shore.
No, that's not on the North Shore. That's kind of like in Burnaby-ish area. But like there's a big tunnel that cuts through Burnaby basically all the way to the Fraser River, and then the train crosses over at that point.
Right.
Pretty cool.
I want to know more about how we build roads and buildings and bridges with respect to earthquake with not earthquake proofing, because that's impossible, but how do we actually design infrastructure to mitigate the risk of something collapsing under an extreme earthquake? And I'm also curious feel free to get super into the weeds technical about this from a nerdy perspective, but like, what technological advances have we had, and how much safer are bridges and roads and buildings now as opposed to 40 years ago for major earthquakes? And how do they test for that?
Yeah, so I'll start it off with the geotech side.
You start by looking at the ground.
You start by looking at the ground. The ground is very important. There's a number of things. So when you say like for how we've improved from 40 years ago, we've come leaps and bounds since 40 years ago. Like geotechnical engineering, I was
worried for a second. You're gonna like, yeah, we haven't made any improvements.
We're actually going backwards.
Well, geotechnical engineering, it's as like a profession, is actually very, very young. It's a very young profession. So we're constantly learning and improving our technology and our understanding of these earthquakes. So whenever there's an event that happens, so example, the earthquakes in Turkey, or the earthquakes in New Zealand, or what happened in Japan, we're always taking as much data from that, the performance of these buildings. Even though it's on the other side of the world, we still want to learn from it. So the first stage of a project, let's say you're building a bridge, the first stage of the project is you drill some holes. You figure out what the ground conditions are. So what type of dirt you're doing, how deep is bedrock, what are your hazards associated with that type of dirt? So then you go to the code. There's a bridge code. You talk to the owner, and you figure out what type of risk that infrastructure is in. So are we talking about this is the only bridge that connects two communities, or is there 30 bridges that connect this community, and one of them is designed for the high performance seismic event? So if you have one bridge that connects one community, that's called a lifeline bridge. So that gets put into a pretty high category of importance, and you have to design to a much higher standard than you would if this is just kind of a small bridge, not really designed for kind of like large transportation, or is not considered as part of the lifeline route. So in Vancouver, I think our lifeline route is Highway 1. So all the bridges there are designed, I believe, to the 1 in 2475 year event.
I think so.
So that's like quote unquote one of the big ones.
What does that mean exactly?
So
Yeah, I have no idea.
So when we talk about like all these hazards and like flooding or earthquakes or any natural event, we quantify it as like a return period. So what's the probability of this happening this year? So the 1 in 2475 year event works out to a 2% chance of happening in the next 50 years. So that's what we've decided is our risk tolerance for our lifeline structures.
Got it. Okay.
So 2% over 50 years. And then that's one of the higher performing structures. Unless you go into like dams, then you have to design to like the 1 in 10,000 year event, which is like very, very strict.
You earlier in the show, you talked about computer models. I mean, are we doing modeling for like the absolute worst case scenario? Like, and if you have an example of this, I would love to hear like, what's a worst case scenario for a natural disaster? Like, what happens if the water levels rise all the way to the bridge? Like, what do you do?
Could that happen?
Well, you try not to design it for that.
Like,
If an asteroid landed right off the coast where Vancouver Island is, do you ever plan like insane scenarios like that?
Nothing like that. We keep it to things we have good understanding for. So like earthquakes, but like it depends what earthquake you're designing. If you're designing to the 1 in 10,000 year event, there's a lot more effort that gets put into understanding that. So there's all these like complex computer models. You take all these earthquake records. So the Canadian Geological Society has all these seismographs all over the province, all over the U.S., and you collect all this data about how the Earth is moving with these earthquakes, because when an earthquake happens, the whole crust of the Earth kind of moves like in a wave, right? So they have all these vibrations and stuff that they record, which is pretty cool. And then us as engineers, we're trying to like take those vibrations and make sure that that doesn't collapse a structure. So make sure your structure doesn't wave, similar to that bridge with the wind, making sure it doesn't get into resonance and then collapse, right? So we're looking at all these factors. We're trying to make sure that the ground doesn't liquefy, which means you shake the ground so much that water comes to surface and your soil then becomes more of like a liquid than a soil. So you go from hard ground to like water kind of thing. So that's a pretty it's pretty devastating.
Like if a city is built on a dike, like a certain city
in
BC here,
like a number of cities.
On a dike? Built on a dike?
well, Richmond,
Yeah.
right? I don't think Richmond would do too well and like if there was an earthquake,
Richmond's
like
the
9
first
out
one
of
to go
10.
out, hey.
I don't know.
Yeah.
Yeah, look, Richmond has a pretty high liquefaction potential.
In other words, you're fucked.
But like, I mean, you do design to it, right? So like a lot of the like high-rise buildings, the bridges and stuff, they're all designed for it, right? This is stuff we consider when we design these structures: is how are they going to perform in an earthquake and not collapse?
Yeah.
is the goal. And so once you understand all these soil conditions, you bring in the computer models, and it's really interesting. Like there's thousands of man hours that go into modeling these earthquakes and checking how the structure is going to respond to it. So is the bridge going to collapse? Is it going to move an inch? Can we accept it moving an inch? If it just cracks, can we repair it within a couple days? Like what's the importance of this? So,
And how closely do you follow the computer technology stuff? Like, are we seeing AI and machine learning sort of trickle down into the specialized applications that are being used? Are we using more of that type of computer intelligence to sort of predict what's really going to happen?
We're getting there. Engineering, like civil engineering, geotechnical engineering, structural engineering, like I said, we're pretty slow to adopt new technologies, and that's a function of like what our risk tolerance is. So if we know something works, we don't like to change it. But we're definitely going to get to a point where a lot of this technology is going to start informing our decisions, and it's going to become like a person just doing the check on these computer systems to make sure that
Like
they're okay.
if anything, AI is worthwhile is engineering, just like the little specifics or anything like
Well,
that.
yeah, these types of computer programs are good at dealing with large amounts of data, of which there's more and more. Like we have more ways to collect data now than we did previously, so there's more data available, and so having tools to be able to quickly sort through this data and make sense of it in a logical way is definitely going to be helpful in the future. So
Yeah.
there's room for these tools to grow alongside these industries, but they're slow to adopt, right? Like you don't want to be first mover in an industry like that. For us, you want to sort of see how it plays out. Go, yeah, that kind of works over there. Maybe we start tinkering with using it over here in theory.
Yeah.
Yeah.
You always start
Slowly.
small and then move it up, try to get it
Yeah.
accepted industry wide, and then you apply it to
Yeah.
what you're doing.
Now, sometimes I drive by this one building in North Van. It's like 50 fucking years old, and I think to myself, the slightest bit of earthquake comes, this thing's fucking down. It's going down. The thing is fucking old, like at least 50 years old, and it's huge. So, I mean, would there be a risk of that thing coming down?
Yes.
Yeah.
There's a lot of structures that are at risk of coming down with a big enough earthquake.
Yeah, no, there's like the AI stuff is going to be interesting to see how it plays out. Like we're starting right now to kind of see like where is this going to take us and how do we apply this. The problem with like things like Chat GPT is that it's confident, but it's also very confidently wrong. And that's not a skill that's not something you're looking for in engineering, right?
No.
You want to be confident that you're right and like and question everything you do.
Yeah, just completely.
It's actually pretty dangerous when someone or even a computer seems like they're right because they're just so damn confident, and that's actually pretty dangerous.
Yeah, like it's not doing any reasoning, right? Like it's pulling from a massive data set.
Well, yeah, we're feeding all these data points and models into it, and it's just trying to figure things out.
Exactly.
So it's fallible because of the data going in
I
too.
feel like we're getting into techie side of things, and we're not techie people right now. We're straight civil. Baby.
Oh yeah, I don't know how any of
Straight
that
civil
stuff
baby.
works.
It is interesting though.
It's super cool.
It is interesting
Yeah.
to see how that's gonna go.
Some of the research I'm interested in is, like I was saying, monitoring bridges and then using like AI, machine learning to figure out, okay, like can we make sense of these large data sets? Can we manipulate it in a way that we can use it for future modeling of different bridge designs? There's like a lot of interesting ways you could look at this stuff. Drones now are being used a lot more in engineering, and you can use what's called LiDAR, which is like a laser imaging technology. And it creates these massive point clouds of, like, I would say millions and millions of points that it creates into like a three-dimensional environment.
Right.
So if you could have AI look at that and make sense of those point clouds and somehow manipulate that data to be able to tell you something, I mean, this is all very exciting, interesting.
Yeah.
By the way, some of the things you guys have been saying, I'm trying to really understand what you're saying, but it's like, I'm such a fucking...
It's pretty technical.
It's fascinating that LiDAR has made it into
Like,
consumer
tell us
devices
the-
now.
Like,
I mean, my
rhetoric-
iPhone has
some of the
LiDAR.
rhetoric is just like, all right, I guess I get it. Whatever you're saying, I believe it. It's just I have no idea what you're saying. It's not on you. It's just I have no.
The nice thing about structural engineering versus, like, to me, things like electricity and magnetism or chemistry is a little bit less intuitive. Like, you can learn about it and you can get to understand it, but I think most people understand, like, you know, if you have your phone and you try to bend it this way or this way, one way is going to be stronger than the other.
Right.
Right? Like, you know that it's easier to break a phone like this
Exactly,
than it
yeah.
is like this. And that's a structural engineering concept. So, and that applies to, like, you have a general idea of why this building isn't falling down right now. Yeah. There's walls and there's columns and there's a roof. And, like, you don't know exactly how it works, but you kind of already have an intuition about how it works.
Yeah.
And that's something I like about
That's a great way of explaining it.
that's something I like about this area of work, where it's like you're sort of just uncovering the math behind things you already sort of understand in the world around you. But you're like, oh, that's why it doesn't actually fall down. It's because
Right.
of this math.
You guys really are the unsung heroes, man.
Okay, I don't think
really
it's
are.
that. I think that, like, our industry deserves more, like, recognition for sure. Especially you compare it. We've been talking a lot about tech, and it's like tech is great. I use technology in my life all the time, but there's definitely, I think, like an overinflated sense of value that we have right now for certain jobs in tech, and sadly, it's like eating up a lot of really, really smart people that
Talk
might
your shit,
otherwise.
Miller.
Like,
Talk
I know
your shit, Miller.
Well, I know civil engineers who, like, very, very talented, smart people, and for their own reasons, they chose to go and work some meaningless job in tech. But, like, and that's fine. That's up to them.
Yeah.
But it makes me sad, right? Because it's like, oh, you know, we need these smart people, like, in this area of work. We
That's
do.
actually a great segue into what MCU wanted to talk about and the points you sent me.
Yeah.
There is a bit of, I wouldn't say stigma, but there is predominantly more men in the industry than women. I mean,
Yeah.
we can talk a little about that. I don't want to venture into something that I have no idea about.
Well, you had two men on your podcast, so
Yeah.
not a great start.
But is it important to get more women involved in the field, right? Like right now we're sitting, I think UBC has a target in their engineering department to get to kind of a 50-50 ratio, but I think they're struggling to get to that target. And I think it's incumbent upon, like, not only the women in the field already, but also like the men in the field to really make engineering a welcoming environment for everybody. Like it kind of has like a stigma for the old white men club, and it's
Same with construction, but I have to say, at least in the Lower Mainland, in the last couple of years, I have never seen so many women in construction, which is amazing to see.
A growing amount of women in construction and blue collar work, which is cool.
Which is great.
which is great.
Yeah.
And it's important to do that, right? Like I think there's a lot of women that would be very interested in the engineering side, like the civil engineering, or even give them tech if they so choose. But that would be very interested in what we're, like, the type of work that we do and the type of problems we solve. But they feel like it's not for them. They feel like they won't be welcomed. And I think it's important for us in the field to go and reach out through the Women in Engineering Society and these other societies that exist to make sure that women do know that they are, like, welcome in the field.
Yeah.
And
To me, it starts at, like, a much younger age, right? Like, employers can only hire, like, talented people that are graduating university. And then like the people who are in those university classes already made a decision when they were in high school to pursue that degree. So what you really need to target is like high school age students and making sure that they understand what like engineering is, and that showing them that it is like an inclusive environment where any person who is good at math and enjoys problem solving, creative thinking in a group setting, like you can come from any background. It doesn't matter who you are. Like,
just give them the opportunity to see if they actually like it or not.
Absolutely.
There's interest in it, and then
there is a stigma about it being like a boys' club, right?
I mean, I guess there's another side of it where a lot of people would argue that more women are not interested in engineering. Therefore, that is why there are less women in the industry. Not because employers overlook women because of the whole stigma and, you know, having an old white guy doing it. I guess, you know, I'm sure there's stats on both ends.
Oh, I'm sure. But I've heard stories from like female coworkers and stuff that through high school they were kind of discouraged from going into the more mathy science by their teachers and stuff like that. So it's important to kind of to acknowledge that, yeah, there might be some slight differences in preference, but I think there's also a lot of pressure throughout school to like go into something that's like more female oriented instead of doing what they might actually want to do, or even like them having the kind of preconceived notion of like, oh, engineering's for men, right? Breaking down that barrier, they might want to explore that a little bit more, and whether or not they go into it at the end of the day is up to them. But but there's a lot of like blocks right now where from a young age they don't really think of engineering as something for them, even though it should be.
Right.
Yeah. Do I think that all else being equal, if people had no barriers in front of them, would it be exactly 50-50 men and women choosing to study engineering? No, I don't think that. There's basically nothing I think that would split down to be exactly 50-50. People will always have preferences one way or another. But I mean, I've heard similar stories from female colleagues. And I mean, I remember being in elementary school and having an elementary school teacher telling our class, like, guys are better at math and science, girls are better at like arts and reading. And she would just say that, like this woman teacher would just say that to our class of young, impressionable kids. Wow. So I imagine that happens not just in the classroom I was in, but in all kinds of classrooms all over the country.
It just plants a seed for them as they
and like
get older. And
the fact that there's already so many men in engineering, you know, for example, my sister, when she graduated high school, decided to study engineering. And it was her and one other person in her class, her friend, were the only two women in the entire class of like 250 graduating students who decided to go study engineering. The only two women, which is fine. But if you're like one of the only women going into it, I could see it being like a bit daunting knowing that you're one of very few people who have like a similar experience or understanding of the world.
Right.
So yeah, like maybe there's preferential differences here and there, but definitely there's other barriers that prevent, I think, more women from choosing to study engineering.
That actually makes sense because the field I'm going into, man, becoming a therapist, clinical psychologist, it's predominantly women. There is a push for more men getting into it, but I have noticed there is a strong, not favor, but like a way more amount of women in that field, and it's cool that you guys bring it to light because I feel like there's definitely women that want to pursue it but are held back or second guess whether they want to do it because of those barriers, and and you would say it all starts from like the top down, probably just like, you know,
it starts from a young age, right? Like it starts from them seeing role models that they can look at,
right?
And it takes time to, like, I understand it takes time to get there, but like I think it could happen a little faster.
Oh, for sure. The whole like women and underrepresented people choose civil engineering because we need more smart people from diverse backgrounds who can bring interesting.
You have to be smart though. Don't even think about doing it if you're not even.
No, even if this is something.
Even if you're just have no idea what's going on.
No, if you have a good work ethic, you don't like. I don't consider myself to be like some kind of genius, but I have a good work ethic.
You are, Millar.
And I know I'm not. I've met geniuses, and I can tell you I'm not one.
You're
but,
an absolute beauty, though.
Thank you. I do appreciate that. Something that I really wanted to hear when I was younger was from someone who's like in the point of their career where I am, sort of a young professional just starting out, to turn around and not just say the typical thing like engineering's so hard, like math and science, this and that. If you are interested in it and you have a good work ethic, you can do it 100%. You don't need to be some kind of genius to do it. You don't need to be some kind of next level person. If you work hard and put your all towards it, I think the vast majority of people could do this. And I think more people should, to be honest.
Yeah.
I guess a lot of people are reluctant to do it because they think they're not smart or mathematically into, like, just not their expertise.
But it's a skill, like anything else you can develop.
Yeah. You need a little bit of like, like I know how to do algebra, like basic algebra. Like you got to be able to do that. No, I wouldn't.
Yeah. But our job is not just algebra. Yeah. And like you can become an engineer and do much less algebra than someone who prefers to do more. Like there's a lot of, it's not super strict within our industry. You can choose to do many, many different kinds of jobs, some with more algebra, some with less.
Yeah.
So I think a great thing about engineering that we talked a bit about the other day is like you can combine your passions with engineering like pretty easily. Matt is very outdoorsy guy, and in his job he gets to work outside a lot.
Yeah.
You know, I'm into tech, and I enjoy thinking about how I could use technology to make bridge engineering more efficient. So there's just, it's that creative problem solving angle. You can take any other interest that you have and like combine it with engineering, which is very exciting.
And what would you recommend to somebody who isn't good at math at all? What can they do in civil engineering, if anything? I'm asking for a friend. It's not me.
There's definitely kind of like the more project management aspect of it. So like project management is like a lot more, you're leaning heavily on your communication skills and then like making sure that, you know, like a good project manager is somebody that not necessarily understands like every technical aspect of a project, but can get people to work towards a common goal, right? And like get everybody in line, make sure the delegations happen appropriately, knowing who's good at what, and delegating to the right people, and then making sure that they're delivering on time and keeping the client happy, engaging with those stakeholders. So a lot more of the like the softer skills. That's a good route. And you don't even, to be a good project manager, you don't even need to have an engineering degree. You can. There's a lot of good project managers who come from the school of hard knocks, and they just learn through trial and error, and they figure it out, and they get pretty good at it.
They're good people, right? Like they're able to communicate, and people enjoy talking with them. They don't rub them the wrong way.
Yeah.
But it's all technically under the field of engineering. Project management, or that's not, project management is completely different. It's something else.
A little bit different, but like
such a fucking goof.
Well, that's a general. That's because I've done this. I've done project and product management. So it's more of a. There's a general. It's a generalized like skill that can be applied. There's project managers and product managers in every type of industry, right? So, and those are skills you can go to a specific school for and learn. Actually, there's plenty of people that actually don't have formal training, and they just kind of they move their way up in the company, and they kind of, you know, and some of them don't last, and other ones that have good communication skills and know how to wrangle people and keep things on budget and keep things on time. A lot of that's a huge part of it too, is keeping things on budget. Can you keep it to a schedule? And that's a huge aspect of it. And especially when in an industry like yours, when we're talking about billions of dollars in investments. So, you know, it's pretty important to manage that properly.
Yeah. And like you said, like it is not necessarily like civil engineering specific, but we interact with project managers on a day-to-day basis. Like that is part of my day-to-day, is updating my project managers on what I'm doing and what I'm working on. Am I slipping on schedule on something? Is it taking a little bit more effort? But like they're key members of the team, and it's like you said, it's something that you kind of come into without needing that like formal education. If you like kind of the construction industry in general, that civil infrastructure type stuff, it's something you can do without having to go through like a 4-year education in engineering. You can go through in a completely different route, whether it's, like you said, working hard and work your way up the company, showing that you got some brains and can problem solve. Again, it all comes down to problem solving. The best thing you can do for anybody is to come with solutions and not just problems, right? Like that's.
Yeah, and you guys both mentioned earlier, but I think this is a good message too, and a good life skill, because no matter what you do, you know, you talked about knowing a little bit about what the other person does makes a huge difference. And me as a project manager or a product manager, in my industry, well, I don't work in tech anymore, but I used to work in software development. So me understanding the language and coming from the perspective of
I was gonna say, sorry, bro, I didn't realize.
I was just gonna say, but understanding the language is super important, and that's critical. And you can apply that to any discipline. Knowing where that person is coming from makes a huge difference.
Yeah, it removes a bunch of pain points, right? Like, there's a lot of communication pain points that can happen just from not understanding the other person. So if you have an idea of what their perspective is and where they're coming from and what their background is, you can work through those problems a lot faster and a lot more efficiently.
Yeah. It's interesting listening to you guys, man, because like at the end of this, now I'm starting to know it's more, there's so much of, that communication and that side of actually collaborative work and understanding just thinking outside the box and adjusting, adapting, and less so, I mean, not less so, but also, the analytical part of it, but there's also that whole side of that, that social dynamic and getting to know it.
Like, I would say I spend as much time in meetings and writing reports as I do actually doing like math.
Yeah, doing the actual gritty nitty work in analytical statistics and stuff like that. Yeah. Well, dude, I mean, I'm looking at an hour 50. Fucking love it. We just went on and on, baby.
Good.
I honestly didn't think
I could talk another hour right now.
Dude, actually, I honestly didn't think we would. Because personally for me, I was like, fuck, I'm a little nervous coming here. I was like, damn, I didn't do any research. And look, I watched maybe like a 10-minute YouTube video on civil engineering, and I was like, okay, I'm fully equipped to do this. But then when I was driving here, and I said to myself, God damn, this is gonna be. I'm gonna let you guys down by not knowing jack shit. But man, I think that was like a very good unpacking of the whole discipline and what it's really about, because I feel like a lot of people have no idea unless they're in the field like you guys.
It does fly under the radar a bit. It's not super flashy, right?
It is not, no.
Product manager.
And like you said, a lot of people are in tech.
App, right?
Yeah.
It's
fuck tech people.
no.
I was just like listening to everything.
There's plenty of very great, valuable tech jobs. I don't want to, but too many, right? Too many stupid jobs. You need more people doing real, like, problem solving.
Helping humanity, man. God damn it.
I have to say, like, one thing I feel like we're learning here is just because you were good at putting together Lego as a kid doesn't mean that you will necessarily be a good civil engineer either, right?
No.
No, not necessarily.
It's like a willingness to be able to learn new things and like always be open to new experiences. Like, problem solving, being creative. Yeah, you'll struggle in engineering if you don't know anything about math or science, but there's other like jobs you can do in engineering that have nothing to do with math and science, like we've talked about.
Yeah.
Right.
So, highly encourage people.
And that's another thing people don't know. There's like a million different streams of engineering.
Yeah.
People just think it's tech, civil, and
mechanical.
Yeah. Well, dude, thank you guys for coming on, man. This is fucking dope. I thoroughly enjoyed it. I tried to understand most of the things you guys are saying, but at some points I was kind of, because I also didn't want to cut you off and be like, oh, can you explain that? Because it would take another like 3 hours probably, right? So I was like listening and thinking, okay, fuck, I hope, like, I think I get what he means. I think that I understand it, but that was really cool, man. A lot of value, learned a lot. I'm gonna listen to this. I listen to every episode and try to like,
I'm excited to see it.
Yeah, man, it'll be good.
Hope people take something away from it.
Yeah, and if you're thinking about civil engineering and you don't know if you want to do it, this should be a promo for every fucking engineering, UBC, SFU, I don't know, fucking MIT, whatever. Appreciate you guys, man. Matt and Millar on the podcast, baby. Enjoy your 24, episode 43. Yeah, I got it right. Nice. Okay. Like, subscribe, share, whatever you need to do on YouTube if you got any value out of this, man. I love you guys. Thank you for all the support. Matt and Millar, thank you, boys.
Thank you.
Anytime.
Beauties, man. Peace. That was good, man.